Good evening. I hope that previous class helped you in understanding the concept of the topic in the chapter solutions. I had discussed you about the abnormal molecular mass, and this abnormal molecular mass, cause of abnormal molecular mass, and this abnormal molecular mass, its cause is I had already been discussed, because due to the association and the dissociation of the solute particle in the solution, right? Now, how to remove this abnormality, it has already been discussed by introducing the Van 't Hoff factor, and so we are in a position on that previous class that how will define the Van 't Hoff factor, and it is represented by I, and this Van 't Hoff factor is the normal molecular mass divided by abnormal. This is the Van 't Hoff factor. So I have taken an example regarding the association of acetic acid and the dissociation of KCl, and calculated the I factor, and on calculation it was found that I for acetic acid 60 by 120, and it comes less than 1. So if I comes to be 1 less than 1, then it is a case of what? That is association. If I comes to greater than 1, then it is a case of dissociation, and if I is equal to 1, then neither association nor dissociation, and the solution is assumed to be the ideal one. So when the solution, a solute undergo association or dissociation, then the ever colligative properties as discussed in the previous class, that is Pa0 minus Pa divided by Pa0 is equal to Xb. Similarly, delta Tb is equal to m into Kb, and then delta Tf is equal to m into Kf, and pi is equal to Crt. So this equation need to be modified if the solute undergo association and dissociation. So that can be modified by introducing the Van 't Hoff factor has already been defined. Now, so this is the previous class topic as it was discussed. Now I is written here, this is normal, since colligative property is inversely proportional to molecular mass. So if the number of particles decreases as happen in the case of association, so colligative property decreases, molecular mass increases, and if the number of particles in the solution increases in the case of dissociation, then what will happen? Colligative properties increases and its molecular mass decreases. So I is this observed value of colligative properties divided by calculated value of calculated colligative properties, or called normal colligative properties. Our I is called total, simply I can also be defined as total number of particles after association or dissociation, or total number of particles present before association and dissociation. So today's topic I want to discuss you about the degree of dissociation. What is the degree of dissociation? That is, it is represented by alpha, and it is the fraction of the total molecules which is dissociated into its ion is called the degree of dissociation. So today's class objective is to calculation of degree of dissociation, that is alpha. This I have to calculate it. Suppose we consider an electrolyte. This is 1 mole of this electrolyte, and it will dissociate to give A plus, B plus, and this is minus. So it is M1, this is M2, this one. So this M1 plus M2, this and so on, that is equal to M. It means to say, if we start with 1 mole of an electrolyte, and it will dissociate to give M ions, and alpha be the degree of dissociation, and alpha be the degree of dissociation. Then number of moles dissociated. Dissociated, that is equal to, that is m into alpha, because it will give m ions. Now number of moles undissociated, that is equal to 1 minus alpha. So what is the total number of moles at equilibrium? So we calculate it, total number of moles. Total number of moles in equilibrium is equal to 1 minus alpha plus m alpha. And since I is equal to, this is observed value of colligative properties, this is the observed value 1 minus alpha plus m alpha. And we have started by taking 1 mole of a substance, so we put here the 1. So when we solve it, I minus 1 is equal to, this is m alpha minus alpha. So I minus 1, there is some, so I write here, this is I minus 1, this is alpha is common, m minus 1 into alpha. So I minus 1, m minus 1 is equal to alpha. If you want to calculate the percentage alpha, then percentage alpha is equal to I minus 1, m minus 1 into 100. So this is the expression. When we solve the numerical, that we apply this expression directly, where I minus 1, m minus 1 into 100, this is called percentage alpha. Now, so we take an example. This is for how we calculate, this is m for AB type. For AB type, if we take it AB, this is AB type, that is NaCl, this is KCl, that is CSCl, etc. So it will dissociate to give, that is A plus and B minus. So m is equal to 2. For AB2 type, this is A twice A plus 2 B minus, A2 plus and B minus. So this is a MgCl2, we write here, this is Mg2 plus and this is twice Cl minus. So what is the value of m here? That is equal to, that is 2 plus 1, that is equal to 3. When we have the problem, how we will put the value of m, so this can be done in this way. Now, suppose calculation of I. Calculate the value of I for MgCl2, assuming to be 100% ionized or dissociated. Yeah, completely ionized. Dissociated. Now we have to calculate alpha. So we have the formula I is equal to I minus 1 and this is m minus 1 into 100. This one. So 100% dissociated, that is 100 by 100, that is alpha is equal to 1 and this is I, and m is equal to mg plus 2 discussed in above, that is mg2 plus, and this is twice Cl minus. So the value of I, that is 2 plus 1 that is equal to 3. So we put here 3 minus 1. Therefore, I minus 1 is equal to 2. I minus 1 is equal to 2. Therefore, I is equal to 2 plus 1, that is equal to 3. So, the calculation of I is very much important to calculate the value of I. Right? So, there is a problem when we use I and not use I. Suppose 4 gram of a problem is given. Problem is given. The problem is probably in the question paper that I see. This is a question paper. So it is written 4 gram of NaOH. So where we consider and where not consider, this is asked in the CBSE examination. That is, calculate the boiling point of a solution. Question is, calculate boiling point of solution when 4 gram of when 4 gram of MgSO4 120 gram per mole molecular mass. MgSO4 dissolved in 100 gram of water. 100 gram of water, assuming, this is assuming to be completely ionized. This one. This is assuming to be completely ionized, and Kb for water, that is 0.5 Kelvin kilogram per mole. We have the knowledge. How we will proceed? First, write the value from this equation. We have to calculate the boiling point of solution, Tb, we have to calculate. Now weight of solute is given, that is how much? 4 gram. And its molecular mass, it is given 120 gram. And that is Wa is given, so this is equal to 100 gram. Now, we have the formula. What formula? Delta Tb is equal to m into Kb. Chunki that formula can only be used if the solute do not undergo any association and dissociation. In the question where we consider I, that's why I take particular example to clarify the concept. You don't confuse. When in the question it is when electrolyte is present and it is completely associated or assumed to be 50% associated, that can be calculated. So m is equal to, we put here I m Kb, and we calculate the value of delta Tb. So I is in this equation it is calculated. This is MgCl2 as previous. That is I comes to be what? 3 by Mg2 plus, and this is twice Cl minus. So I is equal to 3. Now weight, molarity equation, Mb, and this is Wa in gram, and this is Kb, and here is 1000. So we calculate here delta Tb, and delta Tb when we calculated it is in Kelvin. Now it comes to be Tb minus Tb naught. Now what is the value of Tb? Tb we have to calculate, and the boiling point of water is 100 degrees Celsius. We had 273 in Kelvin, that is 373. So on putting this value, we can solve it. So this is the concept to introduce the Van-Hoff factor and how we solve the problem by using this Van-Hoff factor. This is one of the example. Is it clear? So I hope your concept will be cleared by that example. Now we consider another case. So sometimes question asked, calculate the dissociation constant. Calculation of dissociation constant. Dissociation constant dissociation constant for acid. For acid. Now acetic acid, if in benzene, then it is the form a association. If it is aqueous solution, then it will dissociate, and on dissociation, it will form the acetate ion and the hydronium ion or H plus ion. So, by previous knowledge of class 11th, Ka is C square, alpha square, and this is C, 1 minus alpha. So, this is equal to C alpha square, and this is 1 minus alpha. Here, we put the value of alpha from this solution, calculate it y minus 1, m minus 1, not calculate the percentage alpha. And putting the value, we are able to get concentration, that is molar concentration is given. So putting the value of alpha in this equation, and equation, that is alpha, by that expression, we are able to calculate the dissociation constant. So this is all about the degree of dissociation. Now another topic is left. This is called degree of association. So we take another example. So another topic is calculation of degree of dissociation. Calculation of degree of association. Association. Right? Consider in which what is the association? That is the fractions of the molecule associated. It is also represented by alpha. That is the fraction of the molecules associated, molecules associated by total number of moles taken. Total number of moles taken. This is right. Fractions of the moles associated by this one. Now consider the n molecule of A associate to give a molecule AN. Right? If we start with and alpha be the degree of association. Degree of association. Degree of association. So, if we start with 1 mole, then number of moles associated. Number of moles associated is equal to associated n by alpha by n, because alpha is the degree of association and it associates to form n, so this is alpha by n. Number of moles left unassociated, that is 1 minus alpha. At equilibrium, total number of moles is equal to 1 minus alpha plus alpha by n. So I is equal to, similarly, observed value of colligative property, this is the observed 1 minus alpha plus alpha by normal value or the calculated, that is the initial moles taken, or 1. So if we solve it, I minus 1 is equal to alpha by n minus alpha. So alpha is equal to, therefore alpha is equal to I minus 1 by n minus 1, like this. This is alpha. So we write here the another expression for association, for degree of association. Association, simply we can write, due to lack of space, that is percentage alpha alpha I minus 1, 1 by n minus 1. This is the another expression for association. These two, this is for dissociation. So these two expressions are very important to solve the numerical on that formula. So this is the theoretical concept. Now, where n, if it dimers, then value if dimer, if forms dimer, then n is equal to 2. N is equal to 2. So, before that, I have written the questions on the board in order to clarify your concept. Right? So, you see, if 2 gram of benzoic acid, molecular mass, if given, that's okay. If it is not given, then you have the concept, you calculate the molecular mass. Dissolve in 25 gram of benzene, right? Benzene acts as a what? As you know, this is a solvent. Shows a depression in freezing point equal to, shows a depression in freezing point, DF, depression in freezing point is equal to 1.62 Kelvin. So what we, first we write the values from the equation. Write values from problem. So 2 gram of benzoic acid, this is the weight of benzoic acid, 2 gram. Its molecular mass Mb. It is calculated and the value is given in the question, gram per mole, always molecular mass in per mole. Dissolve in 25 gram of benzene, Wa is benzene, 25 gram, right? Benzene shows a depression in freezing point. This is depression in freezing point. If we have the concept like this curve, and this curve, this is solvent and this is solution. So this is graph for TF naught and this is for the solution, and this is that part is delta TF. This is vapor pressure. For your concept, again I have drawn it. This one T. So what we write here, delta TF is equal to, this is TF naught minus TF. This is the expression and this is the concept of the graph, right? So delta TF is given 1.62 Kelvin. Is it clear? So depression freezing point is not. Kf for benzene, Kf is also given. And what is the value of the Kf? This is 4.9 Kelvin kilogram per mole. Now calculate percentage association. Calculate percentage alpha. This is association. This one. And if it forms a dimer, so n is equal to 2. So we have the explained knowledge. This is delta TF. Now we write here the value of n, m into Kf. Now put the value of I. This is I is equal to Wp into Mb, and this one is equal to what? That is Wa in gram. This is in gram. Then we put here 1000 and here is Kf. Now this is delta Tf. Now you put the value 1 point something it is given 1.62. This is 1.62. I will be given. Weight is how much? 2 gram. Molecular weight is 122, and this is Wa 25. This is 1000, and multiplied by much. This is 4.9. When you solve, you will find it at this is I is come to be 0.405 probably. This is 0.405. If you will solve it, then you will find. It is your problem. Expected value already it comes to be 0.405. Now we have the, if we have the concept, then we conclude ourselves or yourself that what steps I have taken, it is right or wrong. Because if the I for the case of association, what is the condition? If I less than 1, then it is a case of association. And it forms a dimer. It means the case of association. And in the case of association, the value of that is I must be less than 1. And in our calculation, we find the value of I is always less than 1. Means our step is right. We are 100% sure the numerical is going on in the, our steps is going on in the right directions. So I is calculated. Now use the formula, percentage, use the formula, next one, this one. So percentage alpha is equal to I 0.405 minus 1 divided by, at its former dimer, minus 1 multiplied by 100. When you solve it, comes to be 99.2 or something percent, you calculate it. This is the problem. So this is, so the chapter is totally finished. Now I conclude in this chapter, starting from the solution. So we get the idea about the different method of concentrations. Then we elaborate our knowledge in the qualitative Henry law, that is the solubility of the gas in the liquid, Henry law, and what are the applications, what are its limitations. Then what is Raoult's law, and what is Raoult's law about the volatile and the non-volatile components, and that is the, and the problem based on that. Then we know about the colligative properties. What is the colligative properties and why it is called the democratic properties? We explained it I explained it very well. Then how many colligative properties? These are 4 colligative properties, and what is the reason for these colligative properties? It will only depends upon the nature of the solute, and it does not depends upon the nature of the, respective of the nature of the solid particles and the other particles present in the solution. And we calculated all the colligative properties, and from that property we are able to calculate the molecular mass. Then we come on the abnormality and the cause of abnormality, how the abnormality is removed, and by introducing the Van 't Hoff factor, and what is the role of the Van 't Hoff factor, how we are able to calculate the Van 't Hoff factors, and what is the degree of dissociation and the association, and how the Van 't Hoff factor play a vital role when we solve the problem. So we should have the concept what is the use to introduce the I, and when we solve the problem, this factor is very important. Thanks a lot. I hope that your concept will be cleared by that examples, and your content in this chapter will be much more, and you go through the book and you consult and solve the assignment assigned in the class, so that you will be get more and more benefited. And my advice to go through the book and CRT, if you will adopt, then it is fruitful for all competitive examination. So that's okay. And in last, I want to say you that if you like, then you like it and share it maximum. Okay. In the next class, I will discuss about the electrochemistry. What is the need of electrochemistry? What are the roles of electrochemistry in our life? Why we are studying the electrochemistry? First, we know the importance of the electrochemistry in our life. We correlate the chemistry with our life. Why we need to study the branch of the electrochemistry or electrochemistry? Because this is a very vast branch. That's okay. I will meet you again with the new topic. I hope you will be happy. Thanks a lot. Thanks for listening. Okay.